All right, so I have to apologize. I'm having some tech issues, so this video is going to be a little bit more lo-fi than what you're used to, but it's going to be really short. So we're looking at another type of reasoning. We've seen inductive reasoning. Here we have deductive. And so this is also another process of reasoning. This process starts with general rules or accepted laws, and it makes conclusions about specific events or cases, very much the opposite of inductive. So, for example, starting with the general rule, if you live in Texas, then you live in the United States. Yeah, that's true. There's no way you could live in Texas and not live in the US. Now, let's look at the specific event or observation of Sam. Sam lives in Texas. Using that general rule about being in Texas causing you to be in the United States, we can then make the conclusion about Sam that Sam must also live in the United States. The specific conclusion is based on that general rule, so this is deductive reasoning. Here, let's say that we're looking at Joe. Joe sees 3 teenagers in his neighborhood. He then makes the conclusion that everyone in the neighborhood must be a teenager. This conclusion is about all people in the neighborhood. That's very general, and he's basing that only on 3 teenagers. So this is inductive reasoning. General conclusion based on specific events. In math, every claim that we make, we have to be able to back it up or justify it. We're only going to do that one of 3 ways, either with a definition, a theorem, or a postulate. We can't do this with anything else. Doesn't matter if we want to say, well, common sense. Well, I think so. My friend told me so. No, everything we justify, that justification must be one of those 3 things. We already know what definitions are, like we should know definition of a midpoint, definition of an angle, etc. Now we're going to look at postulates and theorems. So once we've defined things like angles and segments and all that, we make common sense observations about them that are without a doubt true. This is something we call a postulate. We don't have to wonder whether or not they're true. They're so obviously true, there's no question about it. If something started as an educated guess or a conjecture, and then we can verify that it has to be true, then we call that a theorem. For example, Pythagorean theorem. People noticed that pattern, a squared plus b squared equals c squared. Well, nobody proved it until Pythagoras did. Once it was proven, then we could call it the Pythagorean theorem. So we need to be familiar with a bunch of postulates, and we will be proving a bunch of theorems. Just to give you an idea why we're doing this, this is kind of a nice flow chart of how we're going to make math. First, we define things, and we make observations about those things. And so that's inductive reasoning. We're going to use that to make a conjecture about those observations. Once we make a conjecture or educated guesses, we want to determine if those are true or false. If we can verify that they're true through a logical argument, we're then going to use deductive reasoning to show that it's true. Now, if it is true, we can use that to make more math. If it's false, we ignore it. We don't use it anymore. Throw it out the window. All right, so this is our workflow. We're going to be making conjectures using inductive reasoning and then verifying that those conjectures are true, making them a theorem using deductive reasoning. From here on out, what you want to do is pull out that book and look at the postulates 2.1 through 2.7 on page 127. They're very straightforward. You want to get very familiar with them, and that should do it for you.